मम्मी, ए मम्मी, मम्मी, इधर आना एक मिनट। इधर आ। मम्मी 7 लाख वाली कंपनी भरनी है। जल्दी बोल, प्लेसमेंट के लिए जल्दी बोल।
कहाँ के प्लेसमेंट?
7 लाख कॉलेज से आया, कॉलेज में आया।
सात भर दे।
7 लाख देगी।
कितना होता महीने के?
मुझे पता कितना होगा 7 लाख का।
7 लाख में भाग देंगे ना रेट 12 से।
कितना होता है 7 लाख को 12 से? अब 7 लाख को 12 से भाग दो, कितना होता है?
12 12 24 36 बच्चा 48 12 25 60।
अब महीने की सैलरी कितनी होती है? 7 लाख को डिवाइड करो 12 से तो
7 लाख में नहीं 12
दो तो सही यार।
Modeling technique, right? One thing I want to just clarify, correct? In 4x1 multiplexer, if I'm declaring inputs as a vector, correct? This is a vector. So let me copy this program. So this is a 4x1 multiplexer. Using 4x1 multiplexer, we need to design what? Full adder. How many 4x1 multiplexer is required? 2. One for the sum and one for the carry. Correct. So I have declared the input. 4x1 multiplexer, how many inputs will be there? 4 inputs. Correct. These are 4 inputs. These are 4 inputs. How many select line? 2 select line. This is the output. And we are declaring the what? Y, N1 and N2. N of 0 and N of 1. This is a X. Correct. So this is X of 0, X of 1, X of 1, X of 3. So this is for NOT gate. To getting select line complement. S1 bar and S2 bar. Gate level modeling technique. So this is an AND gate operation. Correct. How many input AND gate is required? 3 input AND gate. Correct. So one is what? Select lines. So another is nothing but input. So this is AND gate and this is the OR gate. So this is complete module is for what? 4:1 multiplex. So using this, we need to design the what? Full adder. So again, module full adder. What are the outputs? Are sum and carry, and then A, B, C, N are the inputs. Correct. Now these are the inputs. These are the outputs. We need a Y. So we are taking the Y. Okay. So this is the way you can do the port connections. When you are instantiating the 4x1 multiplexer, this is a 4x1 multiplexer. This is nothing but what is this? Name of this instance. Correct. So Y is connecting into what? Sum. Here I of 0, I of 1, I of 2, I of 3. We saw that I of 0 is connecting into what? A, input A. I of 2 is connecting into A bar. That we consider as a W1. Correct. Again I of 2 is connecting into what? A bar means W1. So I of 3 is connecting into what? A. Correct. If you remember, by using MSB reduction technique and MSB reduction technique. So how to do the port connection when you are declaring this I as a vector here using this curly brackets. So concatenation of this with the what? Parenthesis. Did you understand this? Is it clear? Similarly, this sum, this select line is connecting into. How this select line is connecting into? Select line is connecting into B, Ci with the curly braces. Did you understand how to do the port connection when you declare I as a vector? And this is for another multiplexer. This is a multiplexer for what? Cout. This is for the Cout. So how you can connect? I0 is connecting into logic 0. One tick B0. I1 is connecting into what? A. I2 is connecting into A. And I3 is connecting into what? One tick to B. So this is a select line connections. B and C, I are the connecting to the select line using MSB reduction technique. Did you understand? So when you do port connection by dot I of A, dot I0 of A, I0 of 1, so we are getting not ports are not connected properly. Correct. So by concatenation, you can do the port connection when you declare I as a vector. Did you understand this? Now this is the module for test bench for the full order. So let us run this program. This is the output when A is 1, B 0, C 0. What is sum is 1, carry is 0. Let us copy this. So this is a full order. 1, 0, 0 is sum is 1. It should be carry should be okay. Let us check this program. I'm using dollar symbol random. This is A, B, C, I. This is sum and out. This argument I'm passing correct. 0, 0, 1 is 0. 0, 0, 1 is 1, 0. 0, 1, 1 is. But in this case, carry should be 1, right? Carry should be 1. And the sum should be 0. So, dash. Okay. You will bring the port connection C out A B C I. This can you check the 4x1 multiplexer? So this is gate 1. N of 0 is the output, S of 0 is the input. So N1, S1. So gate 3, what is the input is? X of 0 and inputs are, this output is X of 0, inputs are complement. S1 bar, this is S1 bar, S0 bar, I0. And next gate is X of 1 is the output. This is S1 bar, S0 into I1. This is X2 is the output. S1 into S0 bar. This is for 0, 0. Select line is 0, 0. 0, 1. 1, 0. 1, 1. Now we are doing the OR operation. OR gate 7. This is my output, multiplexer output. X of 0, X of 1, X of 2, and X of 3. So let us quickly write the test bench to this multiplexer. If this works fine, then we will go for the order circuit. Okay. So can you tell me the multiplexer test bench module TB? What are the inputs are reg type here? Regis. So 3 down to 0, correct? I. Then reg 1 down to 0 of 1. Yes. Then what is correct? Then this is what is the module name I have given is MUX. This is a MUX. MUX 4x1. This is design under test of. Okay, let me go with the connection by default. Let's go initial begin. Initial begin. So let us use the concatenation operation. So generate I comma S is equal to dollar symbol random. We give some time. Relation time dollar symbol display of print I is equal to dollar symbol B comma S is equal to dollar symbol B comma Y is equal to dollar symbol B. Then finish. Arguments we need to pass. So what are the argument is I comma S comma Y. Then I need to end the module N the initial and then the 1. So there is a test branch to this. So when it is I is equal to 0, 0, 1, let's copy this here. So this is I0, I1, I2, I3. When select line is 0, 0, it is selecting the I1. So I want to exhaustively check this for all the possible select lines. Then I should repeat this. This is I'm ending the repeat. Then I'm going to finish. Then I'm going to end the initial begin. Oh, sorry, this one I need to comment. Now this is the output. Let's copy this. Now you see whether it is working as a multiplexer, 4x1 mux. So 0, 1 means it has to select I0. 0, 1 again, I1, sorry, I1, this is I1, it is selecting. 1, 1 is nothing but I3. 0, 1 means I1. 0, 1 means I1. Again 0, 1 means I0, sorry, I1. 1, 0 is I2. 0, 1 is I1. 0, 1 is nothing but I1. Now it is working as fine. So now this is working. Now we need to go for full order using multiplexer. So what is the full order using multiplexer? We did in the last session. What are the full order? How you can build a full order using 4x1 multiplexer? This is one 4x1 multiplexer. This is another one 4x1 multiplexer. 4 inputs, I0, I1, I2, I3. Again 4 inputs, I0, I1, I2, I3. This is the output. And how many select lines will be there? 2 select lines. Correct. So we done with what? MSB reduction technique. MSB reduction technique. So in the MSB reduction technique, what is the decoding logic for the I0, I1, I2, I3 for the sum? This is connecting into the I0, correct? Again, this is connecting into I1 and I2 is connecting into what? A bar. Again, this is connecting into A. Now coming to this carry, what is I0 is connecting into? Logic 0, correct? Logic 0. So what is I0 and I1 and I2 is connecting? Connecting into A. Both these are connecting into A. And this is connecting into logic 1. So this is the one full order using 4x1 moves. 4x1 moves. Now we instantiating this to 4x1 multiplexer, then we can write the full order program. Correct. Now let us coming to this. So first module name is full order. S and C out are the outputs. What are the input is A, B, C, A. Then inputs are A, B, C, A, output are S and C out. So this I am taking while W1. So this is a W1 for what? W1 for this inverter. This A bar I am considering as a intermediate connection. This I am going to consider as a W. Did you understand? So what I need to implement the full order? I need one inverter. 2 4x1 multiplexer is required. Is it correct? Now let us do this. So first I am doing what? Gate level modeling of NOT gate. Gate 1. So output of this inverter is nothing but W1 and input is what? A. Now coming to this multiplexer. Now I am instantiating this mux 4x1 multiplexer. The name is 4x1, mux 4x1. And this is mux 0 I am considering. Now I am doing connections. So in 4x1 multiplexer, Y is the output. So this output is connecting into what? Sum. So then I0, I1, I2, I3, this should be connecting into what? I of 0. So what is I of 0 is connecting into A. I of 1 is connecting into W1, I of 2 is connecting into W1, and I of 3 is connecting into what? A. You can see I0, I1, I2, I3. I of 0 is connecting into A. I of 3 is connecting into A. I of 1 and I of 2 is connecting into what? W1. Inverter out. Now I need to connect the what? Select lines. Select lines. Where I am connecting the select lines? This is S1, correct? This is S1 and this is S0. S0 is connecting into what? CI. S1 is connecting into B. Did you understand? Now I need to do the port connection. These are the inputs to the multiplexer. And then this is connecting into what? Select. So I is declaring as a 3 down to 0. S is declaring as 1 down to 0. So S of 1 is connecting into what? B1. S of 0 is connecting into C. Did you understand? Okay. Now coming to here, how we are writing this is connecting into the, so this is the input, this is the select line, this is the input, correct? This is the input, these are the select lines, the multiplexer. Okay. Now coming to the carry, so Y is connecting into what? CO. I is connecting into 0. I of 0 is connecting into 0. I of 1 is connecting into 1. I of 2 is connecting into A. Correct. Let us see this full order. I think I have confusion. I have some doubts regarding this decoding logic. Let us write this. For the sum, what are the decimal notations is? 1, 2, 4, sum. Correct. Carry decimal notations are 3, 5, 6, 7. 3, 5, 6, 7. So let us find the decoding logic to this. I1, I2, and I3, I0 to I3. So this is A complement and this is A. So A complement for what are the decimal notations is 0, 1, 2, 3. Correct. If you write the truth table to the full order. So A is uncomplemented for what? 4, 5, 6, 7. Now I should do the circles according to my decimal notations. 3 should be circled, 5 should be circled, 6 should be circled, and 7 should be circled. Correct. Now what is I0 is connecting into 0. I1 is connecting into A, I2 is connecting into A, I3 is connecting into. Now let us see this port connection. I0 is connecting into 0, I1 is connecting into A, I2 is connecting into A, and then I3 is connecting into the logic 1. So these are select line connections. B, C. So this is S of 1 is connecting to B. S of 0 is connecting into C. So now we have end the module. So we are reading the test bench. So let me repeat only one time and see the output. Let us remove it. So we have committed. Okay. So I need to commit the test bench for the multiplexer. Here to here I am going to commit the multiple lines.
जल्दी निकल जाओ ना.
Line number 77. Search. One, 0, 0. Sum should be 1 and carry should be 0. Right? So let us connect this into S1 is connecting into CI. This is connecting into B. In this case also we are getting the same. Seems to be my program is correct. Let me do one thing. Let us try this using model sim and check the result.
हाँ हेलो हाँ जा रही है अभी वो बन गया अभी मैं मीटिंग में 10-15 मिनट हाँ ठीक है हाँ हाँ ठीक है जा रहे 10-15 मिनट इनका तो बहुत ही जल्दी आ जाएंगे
So this is marks.tree, a full order dot big file. This is design file. Yes, what is the under file?
हमने भी वो भेज दूंगा मेरे सब चीज खा पी रहे हमरा ना जरूरत है मेरे को उस दिन मेरा खत्म करके नहीं सारा कुत्ता तो मेरा नहीं है तो काहे खाओ ये सब गोली से साइड इफेक्ट होते हैं लीवर कैंसर होता है देख भी होता है साले पागल तू तो पागल है विटामिन नहीं खाता ये सी अब लाया मशीन खा लाला के उसके दे
I'm giving test bench file name is tv.v and model. This is fine. So let me cross check the full order again. So up here it is my multiplexer, correct? This is a 4x1 multiplexer. This is a full order. Okay. Now let us save all. It seems to be this port connection is not proper. Here also I'm getting A1 100 sum is 1 carry is 1. But I should get sum is equal to 1 carry is equal to 0. Can you debug this program? Okay. This is a test display. It is but in the main program we are going SSD and ABC. Main program the full order SSD or ABC. I think display is not a problem, right? This is not a problem actually. I am displaying. However, I can after generating the input and outputs, however I want to display, I can display. That is not an issue here. Okay. This display does not done anything. So after generating the input and output, we are displaying the output. This is not a problem. So this is my full order. Let me open 7. We split full order dot. This is my multiplexer.
खाना सब्जी ठंडा हो चीज अच्छा चीज है
खाले खाले करते मम्मी छोटी बालों में लगा दी
If my concatenation operation is correct, you can see here. So this is I of this will whether this will take I of 0, I of 1, I of 2, I of 3, or this will let us do replace this by 1 and replace this by 0. Now I of 0 is connecting into 1. Save all. Now we are getting the output for this. The mistake is, let's go back to this one. So when I'm concatenating this is I of 0, correct? This is I of 1, this is I of 2, and this is I of 3. I'll make this to 0 in the carry. Correct. I of 0 is connecting into 0. I of 1 is connecting into A. I of 2 is connecting into A, and I of 3 is connecting into 1. Correct. Now 1, 0, 0, sum is 1, carry is 1. Let us verify this list. One zero zero sum is 1, carry is 0. Yeah, again 0 1 1 is sum 0, carry 1. 1 0 1 sum 0, carry 1. 1 0 1 sum 0, carry 1. 1 0 1 sum 0, carry 1. 0 1 0 sum is 1, carry is 0. Again 0 0 1 is sum is 1, carry is 0. So 1 0 1 is sum is 0, carry is. Now this is working as correct. Full order operation. So the small mistake I have done here is when I am concatenating this, so I have connected I naught to I3 to what? 0 and I naught to the 1. Now this is your I naught, this is your what? I1, I2, and this is nothing but I3. Here also this is I naught, I1, I2, I3. You don't understand what mistake I have done. Clear? Now this is your what? S of 0, S of 1. Here also S of 0, this is nothing but S of 1. Is it clear now? It has copied this code. So what is this program is? Full order, right? Full order using 4x1 multiplex. 4x1 multiplex. Did you understand this? So we did few programs on full order, some gate level programs, various using synchronous, multiplexer, orders, etc. Correct. So until now, whatever the gate level we are talking about, I think these questions you can take up and find the answer. So I did this one, correct? I think these two you can easily do. You can implement the 4x1 mux using the 2x1 mux. Now let us continue with. When you are talking about the data flow modeling technique, so we talk about the delays, correct? What delays we talking about the data flow modeling technique? How you can introduce the delay? The regular delay, right? Then you can give the delay as what? Implicit delay, net declaration. During the net declaration introduce the delay. During the declaration of the assigned statement, introduce the delay. So during the implicit declaring of the white data type, you can introduce the delays. Like what delays are there in the gate level modeling? When you are modeling the gate level operation, what are the delays? Okay. So until now, whatever the circuit we have done, correct? Until now, whatever the circuit we have done, we described without what? Any delay. When you're writing the gate operation, gate level modeling technique, did you introduce any delay? So by default, it is nothing but what? Zero delay. So let us take example. When I'm instantiating the AND gate, and followed by the what? Gate name, and then you are writing the output, correct? Output and the input. Output and the inputs. So this is the syntax to instantiating the predefined primitives. Some predefined primitives already available in the Verilog library like AND OR, NOT, XOR and XNOR, NAND NOR, correct? And then buffet 0, buffet 1, inverter 0, inverter if 1, inverter if 0, correct? So what are the circuits we talked about as of now until now? We introduced with what? 0 delay. Now we'll see what delays are associated with the gate levels. Okay. So in real circuit, logic circuit has some delay associated with them. We know that depending upon the doping, correct, the propagation delay. So what circuit will fast works based upon that, there will be delay associated with the each gate in the real circuit. So gate delay allows Verilog used to specify the delays to the logic circuits. So you can also specify pin-to-pin delay can be specified in the Verilog. Okay, when you are writing a program, you can specify the what? Pin-to-pin delays. Okay, so gate delays allows Verilog user to specify the delay through the complete Verilog logic circuits. You can specify the pin-to-pin delay, can also specify. So there are three types
अरे
of
पढ़ाई
delay
कर रहा हूँ यार 2 मिनट रुको यार मैं
from
पढ़ दूंगा
inputs to the outputs of the primitive gates. When you talk about primitive gates, there are three types of delays. What are the three types of delays are? One is rise delay, second one is fall delay, and third one is not the rise fall, this is turn off delay. Turn off delay. So this delays you can specify to the gate. How you can specify these delays to the gate is nothing but, so when you are instantiating the primitive gate, let us take you are instantiating the AND gate, and followed by how you can write the syntax to the primitive gate. What is syntax? You can write the, when you are instantiating the primitive gate, this is a syntax, right? Gate name, followed by the instance name, followed by output by inputs. So when you are instantiating this, what is syntax with a delay is, syntax with the delay is, gate name followed by the what? Delay. Followed by the delay. So delay can be introduced using what? Hash symbol. This is nothing but delay. Delay followed by the what? Gate name and then output, then inputs. Output and inputs. So what is this rise delay, fall delay and turn off delay from input to the output of the primitive gate is? So what is meant by rise delay is nothing but, the rise delay is associated with the gate output transition. Whenever the output transition to what? 1 from what? It may be 0 or it may be X or it may be Z. Whenever it is taking the transition, output transition to what? From 0 or X or Z. This is 0 or X or Z. When it is taking a transition to this, to the 1, so this delay is associated with the gate. This delay we call it as a what delay? This is nothing but rise delay. This is nothing but rise delay. So when in the primitive gates, from the input to the output, the gates are associated with the few delays. Those delays are rise delay, fall delay, and turn off delay. What is the rise delay is with respect to the gate? When it is taking the transition from where to where? It may be logic 0 or unknown or high impedance. When it is taking the transition from 0 to 1, then this delay we call it as a what? Rise delay. Then what is meant by fall delay? It is taking the transition from what? 1 or X or Z. So this delay to the what? To the 0, correct? This is 0. This delay we call it as what? This nothing but we call it as a fall delay. This is fall delay. So the delay is associated with the gate. Output is transition from where to where? 0. 0 to from where? Another value. Whenever it is taking transition towards the 0 from any other value may be what? 1 X or Z. This delay we call it as what? Fall delay. This is nothing but a fall delay. So these are the delays which is associated with the primitive gates from the input to the output. Okay. So then what is mean by another delay is nothing but turn off delay. So what is a turn off delay is nothing but this is a delay which is associated with the gate when the gate taking the transition from where to where? From the high impedance from the other value. Means what is this is nothing but it is 1 or 0 or X. When it is taking the transition towards what? Towards the Z. So this delay we call it as a turn off delay. So turn off delay is associated with the gate output transition to the what? High impedance from the another values. What are the another values is 1 or 1, 0 or X. So this delay we call it as a turn off delay. When delay is associated from 0 X Z to the 1 means rise delay. 1 X Z towards 0 means fall delay. When 1 0 X towards Z means what? Turn off delay. So these are the delays which is associated with the primitive gates. So if the value changes to the X, the minimum of the 3 delay will be considered. If the value is changing to the X, you are going to take how you can calculate the turn off delay is nothing but if value is changes towards the X, then the minimum value, the minimum of 3 delay will be considered. 3 types of delays specified are as follows. If one delay is specified, if you are using primitive gate, only one delay is specified. This value is used for what? All the transition means. What is all the transition means? Rise delay, fall delay, or turn off delay. If the 2 delays are specified, they refers to the what? Rise and the fall. Then what is the value of the turn off delay then? 1 delay is specified means that is specified to all 3 delays. 2 delays are specified means that is corresponding to the rise and fall. Then what will be the turn off? Turn off will be the minimum of these 2. When 2 delays are specified, then turn off should be the minimum of the 2. Did you understand? We'll take an example.